Hello everyone. Let me start with a question. Have you ever ridden a bicycle with a small dynamo attached to the wheel that lights up a bulb? Have you wondered how just the motion of the wheel produces electricity? That's the magic of motional electromotive force. When a conductor moves through a magnetic field, the charges inside the conductor experience a force. This force is the Lorentz force, expressed as F equals Q multiplied by open bracket V cross B close bracket. Here, Q is the charge, V is the velocity of the conductor, and B is the magnetic field. Because of this force, charges separate along the length of the conductor, creating a potential difference. That potential difference is what we call the motional EMF. Now let us derive the expression step by step. Take a conductor PQ of length L, moving with velocity V through a uniform magnetic field B. The magnetic force pushes charges to one end, creating an EMF. The induced EMF is given by E equals B multiplied by L multiplied by V. This means the EMF is directly proportional to the strength of the field, the length of the conductor, and the speed of motion. The direction of this EMF is determined using the right-hand rule. Point your thumb in the direction of velocity, fingers in the direction of the magnetic field, and the palm shows the direction of the induced EMF. But wait, is energy being created here? The answer is no. To keep the conductor moving at constant velocity, an external agent must apply force. This agent does mechanical work. That mechanical work is exactly equal to the electrical energy delivered in the circuit. The rate at which work is done equals the electrical power. Power equals EMF multiplied by current. So, motional EMF is not free energy. It is simply a beautiful way of transforming mechanical energy into electrical energy while still obeying conservation of energy. There is another way to think about motional EMF. We can describe it as if an effective electric field exists inside the moving conductor. This effective electric field is written as E equals V cross B. This induced electric field is not the same as a static field produced by charges. Instead, it only exists because the conductor is moving in the magnetic field. This alternative viewpoint helps us connect magnetic forces with induced electric fields, showing just how deeply electricity and magnetism are related. Now, let's solve a classic problem. We have a rod of length 0.5 meters rotated with an angular speed of 20 radians per second in a uniform magnetic field of 0.2 Tesla. What is the potential difference between the center and the rim? The expression for EMF in a rotating rod is E equals 1 by 2 multiplied by B multiplied by omega multiplied by L squared. Substituting the values 1 by 2 multiplied by 0.2 multiplied by 20 multiplied by open bracket 0.5 squared close bracket. This equals 0.5 volts. So, the induced EMF between the center and rim of the rod is 0.5 volts. This example shows how rotation in a magnetic field generates a measurable potential difference. Here's another example. A wheel with 20 metallic spokes, each of length 0.5 meters, is rotated at a speed of 120 radians per second. The magnetic field is 0.4 into 10 to the power minus 4 Tesla. We are asked to calculate the EMF between the axle and the rim. The formula is the same, E equals 1 by 2 multiplied by B multiplied by omega multiplied by R squared. Substituting the values 1 by 2 multiplied by 0.4 into 10 to the power minus 4 multiplied by 120 multiplied by open bracket 0.5 squared close bracket. This simplifies to 6 into 10 to the power minus 4 volts or 0.6 millivolts. Even though the field is small, the high rotation speed makes the EMF measurable. So let's wrap up. Motional EMF is induced whenever a conductor moves in a magnetic field. For straight motion, the formula is E equals B multiplied by L multiplied by V. For rotation, the formula becomes E equals 1 by 2 multiplied by B multiplied by omega multiplied by L squared. The principle is simple but powerful. Mechanical work is converted into electrical energy. This is exactly how electric generators, dynamos, and alternators work, the backbone of modern power generation. So next time you ride a bicycle with a dynamo, remember, you are literally turning your motion into electricity thanks to motional EMF. I hope this session helped you understand not just the equations but also the elegance of how motion and magnetism combine to create electricity. See you in the next class with another exciting concept in physics.